welcome y'all to this Map Center tutorial video. I'm Mender, and in this video, we'll learn the map for the Quake 2 Remaster. Developed in part by Machine Games and Night Dive Studios, Quake 2 Rerelease is an updated version of the 1997 shooter classic. This remaster includes support for 4K, improved visuals, faster network play, expansions Ground Zero and Reckoning, a Nintendo 64 version of Quake 2, and an all-new expansion, Power of the Machine. Quake 2 is one of the largest collections of player-created maps and a thriving community of map makers and players. Map Center provides a hub for this community, providing support, exchanging ideas, and organizing themed map jam events. If you're interested in mapping, modding, or playing Quake 2 Rerelease, join us on the Discord. Link in the description below.
Thanks, Mender. To start mapping for Quake 2 Rerelease, we're going to need 3 tools. Trenchbroom, our map editor, Eric W. tools, our compilers, and the Forge game data for Quake 2 Rerelease. Links in the description below. First, let's head over to Trenchbroom's GitHub page and click on the latest version. Scroll down to the Assets portion at the bottom of the page and select your OS. We're using a 64-bit Windows, so we'll grab this one here. Next, let's grab our Eric W tools. These are the compiling tools that will turn our map files into playable Quake 2 files. Again, scrolling down to Assets and selecting our OS. Last, we'll grab our Forge game data, or FGD, for Quake 2 Rerelease. This is the game data Trenchbroom needs to populate itself with Quake 2 entities. Click the green code button and select Download Zip. Special shout out to Peril and XAge for providing the game data files. It's worth noting that these files do get updated. If you find yourself having trouble with future versions of these files, head over to the Map Center Discord where you'll find plenty of helpful people willing to lend a hand. Link in the description below. Extract the Trenchbroom zip into its own folder directory. Go ahead and rename the folder to just Trenchbroom. Trenchbroom is a portable application and doesn't require Windows installation. It's ready to run. But first, let's unzip the Eric W tools into its own folder, and then place that folder inside the Trenchbroom folder. Next, open the FGD zip and navigate into the Games directory where you'll find the Quake 2 RE folder. Then navigate to the Games directory within the Trenchbroom folder, grab the Quake 2 RE folder from the zip file, and place it into Trenchbroom's Games directory. Here you'll find games supported by Trenchbroom out of the box, including the original Quake 2. We have just now added support for Quake 2 Rerelease into Trenchbroom. Go ahead and place your Trenchbroom directory in a place you'd like to run it from. Make note of the path as we'll be coming back to this later. Open Trenchbroom by clicking on your Trenchbroom exe inside your Trenchbroom folder. Then select New Map from the splash window. This is the game selection menu, where you can choose which game you want to map for using the menu on the right. But before we select Quake 2 RE, we'll need to configure it by clicking the Open Preferences button on the left. From the Preferences window, select Quake 2 RE using the menu on the left. On the right, we're looking at some fields to configure our game, and set up for the compiling tools Trenchbroom will use to convert our maps into playable Quake 2 levels. First, let's set up our game path. This will be set to the location of your Quake 2 Rerelease installation. Our copy of Quake 2 Rerelease is from Steam and by default can be found in this location. You'll find a link to a text file with this path and the rest of our configuration settings in the description below. Next, click on the Configure Engines button and click the plus button to add a new engine. First, we'll name our engine and then navigate to our Steam executable found here by default. Now, obviously Steam is not a game engine. The configured engine tells Trenchbroom which game application to use when launching our maps. Later, we'll pass the game ID of Quake 2 to Steam and piggyback our launch off of it. Finally, we'll add the paths to our compiling tools, the Eric W tools we added to our Trenchbroom directory earlier. We'll add the Q BSP exe to the BSP field, the viz.exe to the viz field, and the light.exe to the light field. When finished, go ahead and close out a Trenchbroom. Next, let's create a working directory for our maps. We're going to use this directory as a mod for Quake 2 Rerelease, allowing us to launch right into our maps after compiling them in Trenchbroom. navigate to the Rerelease directory inside your Quake 2 installation. The path for that will be found here by default. From there, create a new folder and call it Mapping. Then go into your new folder and create another folder and call this one Maps. This is where we'll save the map files we create in Trenchbroom. With that done, open up Trenchbroom and select New Map. Go ahead and select Quake 2 RE from the right. Make sure Quake 2 Valve is selected from the drop-down menu and click OK. Once inside Trenchbroom, you'll see we have our main view pane, populated by a default 3D object known as a brush. Brushes are what we use to make up the geometry of our Quake maps. At the bottom, you'll find our console pane. To the right, you'll see our inspector pane. And at the top of the window, you'll find our toolbar. Starting with the 3D view pane, you can navigate it with WASD, going backwards and forwards and left and right. Hold down mouse 2 to move the camera around. You can also move around using a combination of the two. And while holding down mouse 2, you can speed up or slow down your movement using the mouse wheel. You can also use the mouse wheel to zoom in and zoom out. You can also use the Q and the X keys to move up and down. In the bottom left corner, you'll find your compass, which shows the X-axis in red, the Y-axis in green, and the Z-axis in blue. A good way to remember that is XYZ versus RGB. The bottom pane is your console window, with an Issues tab that can help you troubleshoot any problems that might pop up. On the right side is our Inspector pane, which is a combination of 3 different inspector windows: the Map, Entity, and Face inspectors. Starting with the Map Inspector, the top section is a list of layers that you can use to keep your map organized while you're editing. You can use the plus and minus buttons to add new or remove layers, and the up and down arrows to sort those layers. The bullet represents the currently active layer. The icons to the right allow you to toggle exporting the layer content to a map file, hiding or showing the layer content, and locking the layer so that nothing can be edited within that layer. The middle section of the inspector are your map properties, where you can set a boundary for Trenchbroom, and the bottom section shows you installed mods that you can use for your map. Here you'll find the mapping directory we made earlier. We won't be selecting this though, as a mod called mapping won't be a requirement for playing this map. Over on the Entity Inspector, the top section shows you the properties for any selected entity in your map. When no entity is selected, the default world spawn entity will populate this area. Each entity will have a class name key with a value of the type of entity selected. Entity properties are key value pairs and can be added or removed using the plus and minus buttons. If we select a value, the middle section will show an information panel about the property, and some values will show a contextual pop-up to populate that value. The bottom section is your entity browser, which shows point entities you can use to populate your map, such as weapons, ammo, and monsters. You can sort and filter these entities using the options at the bottom of the section. Entities are loaded into Trenchbroom using FGD files. Clicking the Entity Browser title bar will show you the FGD we previously loaded. Click the title bar again to return to the Entity Browser. Over on the Face Inspector, the bottom section shows the textures we currently have loaded. You can click the title bar to load additional texture packs. In this case, we're going to load E1U1, and click the title bar again to return to the texture browser. And now you can see all the textures we have loaded up from the pack. Now use your mouse to select the default brush. Return to the texture browser and select a texture to load onto the brush. With your brush still selected, hold down the Shift key to highlight different faces of the brush. Click to load that texture into the UV editor, which makes up the top portion of our inspector. Using the mouse wheel to zoom in, you'll see the white outline represents the selected face of our brush. You can left-click to drag the texture around the surface of the brush. The yellow dot and wheel represent an anchor point and rotation angle of the texture on the surface of our brush. Click and drag the grid lines of the UV editor to resize the texture on our brush. You can use these buttons here to reset the alignment of the texture on the brush. Flip and rotate the texture. The section underneath the UV editor will show you the properties of the currently selected texture, including its name, size, offset, scale, angle, and should it need one, a value. At the bottom of this section, you'll find surface and content flags. Surface flags are properties assigned to just the surface of the brush, whereas content flags are properties assigned to the brush as a whole. Next, let's take a look at our toolbar. The first tool is our default tool and can always be returned to by hitting escape. You can use this tool to create new brushes by clicking and dragging out in your work area. You can also use this tool to select any brush on your map, dragging and moving it around. You can also use this tool to extrude a brush. By holding Shift to select a surface, hold Control as well to pull a brush out from the selected brush. You can also extrude inward to divide your selected brush. Next, we have our brush tool, which we can use to draw outlines for complex shapes. Hold Shift to extrude that shape, hitting Enter to create the brush. The next set of tools are contextual to selected brushes. Starting with the Clip tool, you can select 2 points along the grid, which will draw a line to cut the brush in half. When clipping a brush, use Ctrl plus Enter to toggle between which half of the brush you'd like to keep, or keep both halves. Next is our Vertex tool. Selecting it will highlight different vertices on our brush with yellow dots. You can click these dots to drag your vertices to different positions along the grid. You can also Control-click multiple vertices to move them at the same time. You can also use the Edge tool to select an entire edge, and the Face tool to select an entire face. Next is our Rotate tool, which will allow us to rotate our brush along 3 different axes. In the middle of the arches is a little yellow dot that we can click and drag around, which determines the point from which our brush rotates. Next up is our Scale tool, which will highlight a surface of the brush that you can click and drag to resize. You can hold Alt to select 2 opposing faces, resizing them at the same time, or hold Shift to select all faces of the brush and scale the whole thing. Next is our Shear tool, which will allow you to select the face of a brush and skew it in any direction. Next is the Duplicate tool, which will duplicate your currently selected brush, which you can also do with Ctrl plus D. The next 2 buttons allow you to flip your selected brush either left to right or top to bottom. The last 2 tools are texture locking options. These determine if your texture locks in place or slides around as you move a brush. The first tool applies to a 3D space, while the second applies to a 2D view. Speaking of, from the View menu, open your Preferences window and click the View tab. From here, we'll select 2 panes for our layout and click OK. The work area of our editor has now been split into 2 panes. You can click and drag the divider in the middle to resize the panes, tuck it away, or pull it back out. With the 2D view selected, you can use the spacebar to toggle between front, side, or top-down views. You can also toggle the display of the grid with the 0 key, or cycle through different sizes with the 1 through 9 keys. The grid is made up of Quake units, which we'll go into a little bit more detail later. Last, let's check out the view options. This pop-up window will allow you to toggle the view of different entities in your editor, different brush types on your map, or change display options for brushes in 3D view. Now that we're done with this tour of Trenchbroom, let's go ahead and start making our first map. To get started with our map, we're going to build a room. And the first thing we're going to do is build our floor out. Let's zoom in here on our 2D view and switch our grid to 64 units. When thinking about the grid, you should understand that the player model is about 32 by 32 units and about 56 units tall, and a player's personal space is about 64 by 64 units. A player can also jump as high as 60 units and walk over anything that's about 18 units tall. To make our floor, hold down the Shift key on each edge of the brush and pull it out to resize it like this. That'll give us a room of 640 by 1280. Next, let's go ahead and swap out this texture. We'll search for floor in the texture browser and select this one here. Now that we have a floor, let's create some walls. This time hold Ctrl plus Shift to extrude out new brushes that we'll use for our wall from all 4 sides. Next, hold down Control and click each wall segment to select all 4 of them. Then hold down Shift over the top surface and drag it up to extend the height of the brushes. That looks pretty good, but we're going to need a new texture for these walls. Let's go ahead and look through the texture browser and find something that contrasts nicely against the floor. We'll select this one here because it's got some matching textures we can utilize later. You'll notice, however, the top of our texture doesn't necessarily match the top of our brush. To fix that, shift-click the surface of the brush and move over to the UV editor. Use your mouse wheel to zoom in and then click and drag the texture to reposition it. Perfect. Now, instead of doing that for all of the walls, let's do a shortcut. Shift-click the surface of the altered brush to highlight it. Then, while holding down the Alt key, click the surface of the rest of the wall brushes to copy the texture to them. Let's go ahead and dress these walls up a little bit. Go ahead and Control-click all 4 walls to select them. Then, while holding Shift and Control, highlight the top portion of the wall and extrude inward to divide it like this. We'll do the bottom portion like this, and then just resize the bottom portion to be flush with the floor holding Shift. Next, let's go ahead and just Control-click each one of the middle sections of the 4 walls. Once we have them selected, let's go ahead and swap the texture to this one. And then we'll do the same thing with the bottom section of the 4 walls. Once we have all 4 walls selected, we'll go ahead and swap it to this texture here. That's looking pretty good. Next, we're going to need to enclose our play space. Now this is really important based on how Quake renders its maps. You see, everything outside your play space is the void, and the way light renders is it bounces off all the enclosed surfaces of your map. If there's a gap left open to the void, rendered light will leak out of your map, and you'll be left in darkness. To avoid all that, select the floor brush and hit Ctrl-D to duplicate it, and hold Alt to drag the brush vertically. To avoid a light leak, let's change our grid to 32 and Alt drag it down so that it sits flush atop our walls. Next, let's give this brush a special texture. Let's search for sky in the texture browser, and we'll go ahead and pick this one. As you can see here, the sky texture has some predefined surface flags already selected, the no draw and sky flags. The sky flag will turn our brush into a special sky brush, allowing the game to render the skybox in its location. The sky will also provide us a light source for our map. If we switch over to the entity browser, our world spawn entity will be selected by default. The world spawn contains all the properties for sunlight in our map. Scroll down to the _sunlight key and set its value to 300. Next, scroll down to the _sun mangle key. This property defines which direction sunlight comes into the map. We want to configure ours so that it comes in at an angle like this. The value of sun mangle is comprised of 3 separate angle values: yaw, pitch, and roll. Starting with the pitch value in the middle, you can see that it's already predefined with a -90, which if you were to look at a protractor in the inverse would mean that the pitch of the light is coming straight down. We want our sunlight to come in at an angle, so we're going to set ours to -45 degrees. To set the yaw, we need to understand where the sunlight is coming in from. In terms of a protractor, the x-axis represents 0 to 180 degrees, running left to right, and the bottom of the y-axis would be 90 degrees, whereas the top of the y-axis would be -90 degrees. We want our sunlight coming in from the top of the y-axis, so we'll set this value to -90 degrees. As for roll, well, it does nothing. To highlight the shadows that our sunlight's going to cast into our map, let's go ahead and create a column in the middle of our map. Over on the 2D view, go ahead and draw out a 4x4 brush onto the map. You'll notice in our 3D view there is no brush. That's because the brush was drawn up here next to our last selected brush. It also retained the texture of the last selected brush. We don't want that, so delete it and go ahead and select this texture on the bottom of our wall. We're going to use this texture for our column. Go ahead and redraw the 4x4 brush onto your map. Use the Shift key to extend the top and bottom surfaces of the column. This one went a little too far, so we'll just lower it back down. Next, let's go ahead and extrude inward on this column, and then we'll drag the two sides of our column to create an overhang. Perfect. That should give us some good geometry for casting shadows onto our map. With that done, let's go ahead and create an elevated section onto our map. We're going to create a ledge by selecting the clip tool, and we're going to go ahead and divide our floor brush like this. Hit enter, and then holding shift will raise the face of this brush up to here. Now to texture this surface of the wall, we'll go ahead and use the same trick we used earlier to copy the texture from another brush. Now we'll need a spawn point for the player to enter the map. Over on our entity browser, go ahead and search for player. We're looking for info player start. We'll go ahead and drag that into our map and use the rotation tool to turn him the right direction. Now that we have our player spawn point, let's go ahead and give him some weapons and ammo. Go ahead and search for shotgun and pull the super shotgun entity onto the map. And for ammo, we're going to search for shells and put the ammo shells entity onto the map. With all that weaponry, we're going to need something to shoot. So let's go ahead and add a monster up here. I'm going to add the Berserker, pulling him into the map. He's facing the wrong direction, so I'll just use the flip tool to turn him around, and then we'll just drag him over here. Over in the Entity Inspector, we're going to set a spawn flag for this guy. We're going to click the Ambush flag. This will prevent him from aggroing until he has direct line of sight to us. With that done, we're going to need a way for the player to reach the top of the ledge and engage our monster. For that, we're going to create a lift. Now, we've already covered a few point entities while making this map, and if we deselect this guy, we also have our world spawn entity. But there's a third entity type, and that's a brush entity. Using a 16 by 16 grid, let's go ahead and draw out a brush that we'll use for our lift. We'll go ahead and drag it into position here. I'll hit the C key, which is a hotkey for the clip tool, and I'll just go ahead and clip this corner off the lift here, and this corner here, hitting Control Enter to toggle between halves. That looks good. Let's go ahead and give it a different texture. In our face inspector, we'll use the texture browser to select this texture here. Now that looks good, but we'll probably want another texture for the sides of the lift. Let's go ahead and select this face here and this texture here. Now rather than just copying with an Alt click, we're going to hold Alt and drag across surfaces like this. Perfect. Now it's time to turn our lift into a platform entity. The thing to know about the platform entity is that it needs to start in the up position. Hold the Alt key to drag the lift to the top position. Go ahead and right click on it and select Create Brush Entity. Select Func and then Plat. We have now created a platform entity. Move over to the Entity Inspector and you'll see that our entity has a class name of Func Plat. We only have one property value that we need to set for this entity, and that's going to be height, which is determined by the height that it's going to travel, which if we move this brush up a bit, we'll see is 128 units, minus the 16 units for the platform, so that'll leave us with 112 units. Next, with the brush still selected, we're going to go ahead and move over to the face inspector, and under the content flags, we're going to go ahead and check the detail flag. What this will do is it'll remove the brush from consideration when light is rendered. This will improve the performance of the compiling tools and reduce our render time. In fact, it's good practice to apply the detail flag to any brush that isn't used to contain the light into our map. You can use the View Options pop-up window to toggle Show Details to turn detail brushes on and off when viewing your map. Now that we have a fully playable map, Let's go ahead and save this guy real quick. From the File menu, go ahead and select Save Document, and we'll save this file in the Maps directory in the Mapping Mod folder that we created earlier. We're now ready to compile our map. Head up to the Run menu and select Compile Map. In this window, we're going to create a couple of profiles. Click the plus button to create our first profile and name it Full Bright. This will be our quickest rendering option, rendering the map without any lighting. Click the plus button here and select Run Tool. In the tool path, we're going to add a variable of $BSP between two curly braces. This variable will refer to the BSP compiling tool that we configured previously in the Preferences window. By using variables in our toolpaths here, we won't have to worry about updating these profiles should we ever update our compiling tools in the future. Next, go ahead and add this parameter and click the checkbox for Stop on Non-Zero Error Code. All these parameters can be found in the text file linked in the description. Now we can compile, and our map is successfully rendered in full bright with a finished with exit code 0 message in the console. This message lets us know that everything compiled fine and there were no errors. A full bright render is a great way to check your work quickly, but not suitable for play. Next, we'll add a fast render profile. This will give us a rougher lighting render that won't take as long to compile as a full render. Go ahead and add a new tool and use the BSP variable that you used before using the same parameters, and click the Stop on Non-Zero Error Code box. Next, we're going to add another tool, and this time we're going to use the variable viz to reference our viz compiler. Go ahead and add the following parameters for this tool, and check the Stop on Non-Zero Error Code box. We're going to add one last tool, this time using the light variable for the light compiler. For this, we'll add the following parameters, again checking the Stop on Non-Zero Error Code box. Now we have our fast render profile complete. Let's go ahead and add one more profile, and this will be our full render profile. Go ahead and add the BSP tool as you did before using the same variable and the same parameters. Check the Stop on Non-Zero Error Code box. Then go ahead and add the viz tool again using the same variable and the same parameter and clicking the Stop on Non-Zero Error Code box. And last, we'll add the light tool again using the same variable but with a new parameter. Click on the Stop on Non-Zero Error Code box, and now you have your full render profile set up. To recap on these three profiles, you can use your full bright to render extremely fast but without lighting, a fast render option which will give you lighting and usually compile within 1 to 5 minutes, and a full render option which will give you the best render quality, something that's ready to publish, but usually takes anywhere between 10 to 30 minutes to compile depending on how big your map is. With that said, we'll go ahead and compile on a full render, as our map is extremely small and it won't take any time at all. And like that, we're ready. Let's go ahead and launch the game. Here you'll see our launch engine we configured before, but before we do that, let's go ahead and add some launch parameters. These parameters include app launch, which tell Steam which game ID to go ahead and load, skip movies, which will skip past the intro movies, bind F10 to quit so that we can exit out of the game quickly. It'll set the game mod to mapping, set the map dynamically to the map that we're exporting, and enable cheats within the game. Let's go ahead and launch the game and give our map a quick playtest. And here is our finished map, fully rendered. But for quick reference, this is what it would look like in full bright, and this is what it would look like with a fast render, and this is the full render. You'll notice how the shadow lines are a lot less jagged with a full render. We have cheats enabled, so let's go ahead and bring down our console by pressing the tilde key, and we're going to enter two commands, no target and no clip. This will allow us to fly around our map and take a look at our work without triggering any of the monsters there, and everything's looking pretty good, so let's go ahead and give it a run. We'll go ahead and bring the console back down, and turn off those commands by entering them again. Let's go ahead and grab our super shotgun and some shells, and we'll take the lift up to the Berserker and give him a quick frag. And there you have it. We've completed our first map. But before we wrap up this video, let's go ahead and review our exported files. In our maps directory within our mapping folder, you'll find firstmap.bsp and firstmap.map. The BSP file is the map file that Quake 2 loads, and this is what you'll share. And the .map file is of course your Trenchbroom file that you'll use to edit your map. The rest of the files are logs and debug files that you can get rid of when you're finished. Thank you for joining us for this tutorial. In our next video, we'll dive deeper into some of the features of Quake 2 Rerelease, expand on content and surface flags and entities, setting up goals, navigation, and touch a little bit on how to set up deathmatch. If you like this content, like, subscribe, and join us on the Discord. I am Doom-Shakalaka, and we'll see you next time.